In this question, we want to determine whether the system of equations is consistent or inconsistent, and then to more specifically determine which of the 8 possible scenarios it is. So we have these 3 equations. So what we do is, first of all, determine whether or not any of the planes are parallel. With the normals 1, 1, 1, 4, -1, -1, and 2, -1, -1, we see that none of the planes are parallel. And so that means that we either have one point of intersection or one line of intersection, or we have no points of intersection. In other words, the 3 planes form a triangular prism. Well, the only way to determine what it is to do our matrix work. So we're going to multiply the first row by 4 and the third row by 2 in order to get our entries in the x column the same. And once we do that, we can multiply this row by a quarter, get it back down to 1, 1, 1, 2. Subtracting row 1 minus row 2 and row 1 minus row 3 gives us this as our entries. At that point, we can see that we might recognize right away that row 2 and row 3 are scalar multiples. If we don't, we can multiply row 2 by 6 and row 3 by 5. And after we do that, subtract row 2 minus row 3 to eliminate the y entry, to make this value be a 0. When we do that, we see our last line is 0, 0, 0, 0. What that means is that it's not contributing anything to our understanding of the it's not contributing anything to the understanding of the intersection. So we can think of it as though we've got a plane x plus y plus z equals 2 and another plane 30y plus 30z equals 90, or more simply y plus z equals 3 if we want to reduce it. But anyways, what we can do once we realize that, let's let our z coordinate equal 0. So think of it as though we've discarded this row of zeros here. In the second line, let our z coordinate be 0, solve for y, and we see that our y coordinate is 3. We can take those values and plug them back up above, and we get an x value of -1 from the first row. So we know that one of the points on the line of intersection is going to be -1, 3, 0. And now we simply need to determine what is a direction vector for that line. And we can do that by crossing the normals of the first 2 planes. And remember, all 3 of them intersect in the same line, so we can kind of discard the third one and just focus on the first 2, since the third one intersects at the same line as the first 2. In doing that, in crossing these 2 normals, we see that we get a vector of 0, 5, -5. Since we're using it as a direction vector, we can multiply through by 1/5 and make it 0, 1, -1 to put it in its simplest form. And so we can say that our line of intersection is r equals -1, 3, 0 plus t times 0, 1, -1.